Hi, is this Alexander?
This is he.
Hi, I have a homework problem that I'm totally stuck with. I don't even know where to start.
Okay, what's the topic area?
It's logarithms
Awesome.
or logs. Okay,
Yeah, they are the big.
I'm glad you're. Okay, so it's giving me this long um, uh, situation, and it's asking me to, I guess, contract it.
Contracted. Okay, so what is the, and you said long situation.
All right, it's three, and then log. And then the four is like low. So I guess that was a base. Is that what they say?
It is a base, yeah. So whenever the number is like lowered like that, that means that's your base. And I'll talk about what that means a little bit.
Okay.
Go ahead and
And then the backup no longer base will be X.
and the terminology for
Like,
that. So a lot of these terms are really like overly fancy, but this guy would be the base, and anything that's
okay.
inside the logarithm would be called the argument.
Okay. So three log base four with argument X.
Yep.
Okay.
You could
So
also
I'll try to read the next like
you could
that.
also say of x.
So of X. Okay. Um, so plus two log base four of Y
Cool.
minus log base four of Z.
Cool. And was that all the terms?
Yeah.
Okay. So two things. First, I'm going to make a similar example and use that to explain it to you, and then see if you can walk me through your own example after I've done that, if that sounds fair to you.
Yeah, that sounds good.
Okay. Secondly, while I do that, I'm going to explain some things about logarithms as I'm doing this. So just to give an example, let's say we had 7 log base, I don't know, 8 of v plus 3 log base 8 of w minus 5 log base 8 of q. Just to emphasize that the letters don't really matter. You just got x, y, and z in your case. Um, so the way this works as far as contracting is that there's some log properties. I'm going to actually put them in green. I think I can fit them in between these examples. And so one of them is this. If you've got, first of all, the bases have to match. So notice in your example, all the bases were 4. And when I made that
Right.
example, I made all the bases 8. It doesn't really matter what that base is, but they do all have to match for these properties to work.
Okay.
So in the description, you'll notice I'll say log base b, so any base of anything, plus log that same base of anything. What you can do with this is you can write this as log base b of the product of those arguments. So it looks scary, but all it's saying is if you're adding two logs, again, as long as the bases match, you can multiply whatever was in both of those logs and write it as one log. So that's one of the
And
properties.
that
Mhm.
so the that multiplication would be the argument, I guess. That's what we call it.
Yep. So if you've got argument x here, argument y here, and its addition, you can write it as argument x times y.
Okay, that makes sense.
There's also one for subtraction. So if I have log base b of x minus log base b of y, well, when it was addition, I wrote multiplication. So if you just had to guess, what do you suppose is going to be in the argument this time?
Uh, Division.
Mm-hmm. Yep. And one more property we need is that if you've got log base b of anything raised to a power, you can actually like bring that power down in front and you can multiply.
Okay.
There are more log properties, but these are the only ones we're going to need for these examples. Um, Now, remember, this is an equal sign, so you can go both ways with any of these properties. Keep that in mind as well. So you
Okay.
don't need a whole new set of properties if you're expanding a logarithm as opposed to if you're contracting one like we're going to be doing here. Do these
Okay.
in theory so far?
Yeah, that makes sense.
Okay, so let's look at this example. So I'm going to also point out which properties I'm using for each one. So for this first one here, notice I have a number in front of my logarithm. And so what I can do is I can bring that back up as a power. So for this one, I can write log base 8 of v to the 7th. And that's just me using this property here. It's just the equality is going the other way in this case. So far, so good? Okay. So your audio is breaking up just a little bit. Go ahead and type out right quick because we have a text thing. Just let me know if you can hear me. All right, cool. You can. So I'll keep checking in with you to see when I can hear you again. But if you can keep hearing me, then what I'm going to do is just finish these other two using this property. So with this one, I'm going to write plus log base 8 of w cubed. So here I'm just bringing the 3 up minus log base 8 of q to the 5th. So notice I brought the 5 up. Now the reason I needed to do that was because notice even though these log bases matched, the arguments inside were different. And so I can't just start doing these properties. Like I can't do log base 8 of v and log base 8 of w. I'm adding those, so I multiply w and v. I can't do that here because of these numbers in front. It's like they're different terms. But once I bring these powers up, now the argument to this log is just v to the 7th. The argument to this log is just w cubed. The argument to this log is just q to the 5th. So now I have a bunch of logs all by themselves, if you like, and I can use these two properties over here. So if I'm using these two properties for addition, it becomes multiplication. So I have log base 8 v to the 7th times w cubed, and then minus log base 8 of q to the 5th. Okay, and that's just me using this property right here, that if I add two logs and the bases match, I can multiply what's inside. It's just that what's inside in this case is not just a simple single variable, it's an expression. It's like v to the 7th. But that doesn't matter. Even if I had a mile-long thing inside of here, I can still say that's what's in the first log, multiply it by whatever's in the second log. And so that can be very useful for if you want it to expand these out or contract them. That's a great way to break everything up. So my final thing would be that, well, I've got log of some stuff, right, minus log same base of some stuff, and that's this property right here, that if I subtract two logs, I can just turn that into a division. And so this is going to become log base 8 of, so all this goes in the numerator because that's what's in the first log, that's what's in the positive log here, right? And then this is going to go in the denominator, this q to the 5th, because I'm subtracting all of that. And there we go. So in this example I gave you, it's all the bases matched, but I had numbers in front, so I had to bring them up. And then I just used the additive and subtractive properties right here. And so I have contracted this. Instead of having the 3 separate logs and numbers everywhere, I've squished it all together. So it's just log base 8 of all this right here, v to the 7th, w cubed over q to the 5th.
Hello, Alex?
Hello, I can hear you. Okay, apologies for that.
Okay.
So were you able to see?
Cool. Yeah, no worries.
Were you able to hear / see all these steps, and was there any questions you had about this process?
No, I have those notes. I think, can I work through my example and you just sort of guide me?
That's what I was going to ask you to do to make sure you do understand this process. So yeah, feel free.
The log base 4x plus 2 log, sorry, I'm just recopying a new
That's
page,
fine.
is 4 of y, log base 4 of z. Okay. So first we need to take to make them like terms, we have to take the 3 that's out front and the 2 that's out front and throw them up into powers, right?
Yep.
Okay. So we're looking at log base 4 of now x to the third, okay, plus log base 4 of y to the second, and then minus, this one didn't have one, so it's just log base 4 of z.
Cool. So far, so good.
Okay.
Yeah.
That's one of those properties. The next one we have addition. So let me look at my notes. That means we got to multiply those together. So log base 4 and then parentheses x to the third times y to the second, and then close parentheses, minus log, nothing changed there, log 4, base 4 of z. And then we have subtraction, which is, in my notes, division. So log base 4, open parentheses, and then the top of the fraction, I still have x to the third times y squared. And the bottom, I have just z. And then close parentheses. And I guess, yeah, that's it.
That's it.
I can't go any further.
Yep. So once you once you've got one log, you've gone as far as you're going to go, because that's the goal, is to write everything as one logarithm.
Okay, that wasn't too bad. And that you said for expanding and contracting, I just need those 3 rules in the middle for the power and then adding and subtracting.
Yeah. So if you start doing like algebra with logs, or there's other stuff involved, there are more properties, but these 3 are like, you know, off the top of my head, these are what you need to do expansion and contraction problems.
Okay, yeah, because that's what this homework section's on. So I think I'm good for now. I'm going to try the rest, and if I get stuck, I will try to come back.
Sounds good.
Awesome. Thank you so much, Alex.
No problem. Good luck.